This question explores models for the height of water in a cylindrical container as water drains out. The diagram shows a cylindrical water container of height 3.2 meters and base radius 1 meter. At the base of the container is a small circular valve which enables water to drain out. If closes the valve and fills the container with water at time t is 0, if opens the valve, she records the height, h meters, of water remaining in the container every 5 minutes. If first tries to model the height using a linear function, h of t is equal to at plus b, h of t is equal to at plus b, and question AI, find the equation of the regression line of h on t. And we choose stat, edit, L1 it's time, L2 it's height, and then stat, calc, and we need what? Linear regression, and x it's time, it's independent or explanatory variable, y is dependent or response variable, it's height, frequency is L3, and we get the result. So you can see that A is negative 0.134, B is 3.1, so h of t is equal to negative 0.134 t plus 3.1. The next, interpret the meaning of parameter A in the context of the model. 1 mark. What is A? A is gradient, and what does it mean? In general, y is mx plus c. What does it mean? It means that if or when x increases by 1, y changes by the value which is equal to gradient. When gradient is positive, y increases. When gradient is negative, y decreases. So here it means that when t increases by 1, h changes by this value. Negative, it means decrease. So we can say that for every additional minute, because t is measured in minutes, so for every additional minute, height decreases by 0.134 meters. Or you may say that it means the rate of change of height of water in meters per minute. The next, Eve uses the equation of the regression line of h on t to predict the time it will take for all the water to drain out of the container. And question is, suggest why Eve's use of the linear regression equation in this way could be unreliable. 1 mark. So unreliable because we cannot use h on t graph or equation to estimate or to predict t on h. So to predict or to estimate t on h, we should get similar equation, but t on h, what does it mean? It means that t should be y and x should be h x t y, and you get t on h, and you can estimate or predict time for given h. So here we say the next, that unreliable to use h on t graph or equation to estimate t. It should be used t on h equation or graph. Eve thinks she can improve her model by using a quadratic function h of t, which is pt squared plus qt plus r. And question bi, find the equation of the least squares quadratic regression curve, 1 mark. So using the same data, but we need quadratic regression. Time, it's x, it's independent, it's L1, y, it's height, it's dependent, L3 is frequency, and we get the result. ABC, so h of t is 0.002 t squared minus 0.174 t plus 3.2. And the next question. If uses this equation to predict the time it will take for all the water to drain out of the container and obtains an answer of k minutes, find the value of k, 2 marks. So k is time, or t, when h is 0. So we should solve this equation, and you can see that it's quadratic. You may use a formula with discriminant, or we can just plot a graph of this function, window x, for example, from 0 to 40. Height, maximum height is 3.2, so y may be chosen from negative 0.54 to 3, for example, and we can see that this point is required, this root or x intercept, and then just calc 0, left bound, right bound, and guess, and we get that it's 26.4 minutes to 3 significant figures. And the next, hence write down a suitable domain for Eve's function h of t. Domain, what does it mean? With possible values of t. T is time, so time changes from 0 up to when it is empty, so up to this value. The next, let V be the volume in cubic meters of water in the container at time t minutes. Let R, capital R, this be the radius in meters of the circular valve. Don't get confused, it's not a radius of a cylinder, because radius of a cylinder is 1 meter. 1 meter. Then, Eve does some research and discovers a formula for the rate of change of the volume, and this formula given. And question C shows that dH over dt is equal to this. So, what is V? V, it's a volume over cylinder, and volume over cylinder is what area over base, and it's circle with radius 1, so it's pi 1 squared times height. And differentiate with respect to time, we differentiate both sides with respect to time, so we get dv over dt is equal to, it's just a constant, it's pi and times 1, and h, it's some function, unknown function of t, so it becomes dh over dt. Then dv over dt is equal, we can actually continue, and it is equal to my negative pi r squared root h, and then you can see that pi cancels and we get that dh over dt is equal to this as required. The next, d. By solving the differential equation, dh over dt is negative r squared times root, so we need to solve this to get and show that the general solution is given by h is, so we should get this. And how to solve this differential equation? By separating variables. We can see dh, so it becomes dh divided by a square root of h, but square root of h is h to the power of a half, and in the denominator it becomes to the power of negative a half, is equal to some constant negative r squared, this root, and dt. Then integrating both sides, we get it's x to the power of n, and integral is equal to what? +1 for this exponent, and divide by the obtained power, so it's x or h to the power of plus a half and divided by a half, so it becomes h to the power of a half, and to the power of half it's what? A square root of h, and multiplied by 2 is equal to constant, and integral of 1 dt is just t, so it becomes negative r squared, this root, t, and plus some constant of integration. Then we should get like this. Dividing by 2, we divide each term by 2 and get, or let's rewrite, it becomes square root of h is equal to negative r squared, and a square root divided by 2 or square root, but under the square root it becomes divided by 4, and then t, and plus constant divided by 2, it's just another constant to be found, so it doesn't matter. You may write c over 2, but it's just another constant, so you may keep saying constant or write a, it doesn't matter. Then this value divided by 4 is this, and it becomes root of h is this constant c minus r squared and root of this value and t. Then h, it becomes this, and squared. And how to get this? We factor out this value, but since it is squared, it moves out as square root and then squared, so it becomes just this value, because square root squared is just a number, and it remains what? This constant divided by this root, but it's constant divided by a constant, it's just another constant. I keep c, but you may, in general you may write another, for example b or something like that, and minus r squared t. Then, if measure the radius of the valve to be, it's this capital R is 0.023 meters, let capital T be the time in minutes it takes for all the water to drain out of the container. And question E, use the general solution from part D and the initial condition h of 0 is 3.2 to predict the value of T. T is height of capital T is equal to 0 for box. So this is given, but we should find the value of C firstly. So h of 0 is 3.2, so 3.2 is equal to this, and C minus 0 squared. So C becomes what? This divided by this, and then square root. 3.2 divided by this, and then square root. Let's check. Yes, it's correct. So C is 0.013468 and so on as exact. We should keep the exact here. Let's check. Okay, and 7 and zeros. Okay, so 7 and 0, 0. Okay, so then just consider h of capital T is equal to 0. So it becomes this value, this C, let's write just C and R, and then substitute, and capital T squared is equal to 0. So it to be 0, it means what? It should be 0, so it means C is equal to R squared capital T. So capital T is equal to C divided by R squared, and it becomes it's C divided by 0.023 squared, and we get the required time. Let's check. Yes, it's 25.5 to 3 significant figures minutes. Yes, it's 25.5 minutes. The next, Eve wants to use the container as a timer. She adjusts the initial height of water in the container so that all the water will drain out of the container in 15 minutes. And question F, find this new height. 3 marks. So there will be new h of 0, but h of 0 depends on what, or actually, or vice versa, this C depends on the initial condition, so that this value T is 15 minutes now. So how can we solve it? When h is 0, we get that what? Constant C is equal to R squared T, and now it is required that this T should be 15 minutes, and hence we can find new value of C. So it's 0.023 squared and times 15. Let me check. Yes, it's correct. It's exact. 0.00793. It's new value of C. And what is h of 0, the initial height which is required. H of 0, it's what? It's this value times c squared, just when t is 0. And it becomes, it's our c, then squared, and multiplied by this, and we get 1.11 to 3 significant figures meters. And the next question: if has another water container that is identical to the first one, she places one water container above the other one, so that all the water from the highest container will drain into the lowest container. If completely fills the highest container, but only fills the lowest container to a height of 1 meter shown in the diagram. At time t is 0, if opens both valves, let capital H be the height of water in meters in the lowest container at time t. So h of t is height at any moment of time of this lowest container. And gi shows that dh over dt is equal to this. So water from highest, and from the previous we know that rate of change of height dh over dt is equal to something, and actually radius is 1, so if we multiply area over base is constant, so it's actually will be proportional to the volume of water at any moment of time. So as rate of change of amount of water per second, we can use the dh over dt. So idea is the next, that water from the first becomes water into the second, and also there will be water out from the second. So if we consider lowest, there will be water in and also water out, and the resulting rate of change, we should what? Add this rate of change and subtract this, or this rate of change should be negative because it's water out, and this rate of change should be positive because it's water in. And since it's identical cylinder, and using the previous result and height for the second, for this lowest, it's capital H, so dh over dt is equal to what? It's this general formula. It's this general formula. Where is it? This general formula dh over dt. The radius of the valve is the same, and minus, so it becomes negative r is 0.023, negative r squared, a root (70560), and also capital H, and water out from the highest, from the first, is this result, actually this with c to be equal to this, and its height at any moment of time, but we need rate of change, so we should differentiate it firstly. So we should consider the next, that h is equal to this 17 something and c minus r squared t and squared, and c is equal to, r is the same and c is equal to, we should be exact, 0.013468 and so on. And we need rate of change, dh over dt. So we should what? Differentiate with respect to time. And you can see it's something squared. And how to differentiate it? Using chain rule. So something squared and derivative, it becomes 2 times this something and something derivative. It's just chain rule when there is power. So it becomes, it's just a constant, and it's constant multiplied by a function, it becomes constant multiplied by the derivative, and derivative becomes 2. And to this expression, and this expression derivative, and you can see it becomes constant minus r squared t derivative, and derivative of just, and you can see difference, and derivative of difference is difference of derivative, so it becomes c derivative, which is 0, and minus r squared t derivative is just negative r squared. So it becomes negative r squared and c minus r squared t. And notice that we get it to be negative. Why? Because with respect to the first cylinder, rate of change is negative because height of water decreases. But with respect to the second, it's water in, so we should consider this rate of change to be positive. So we should consider plus instead of minus. So it becomes plus 2, or actually we can multiply. Oh, we can do the later. So 2 times this 17 and times r squared and c minus r squared t. And if we expand and simplify, we should get like this. Let's check. Let's check. And you may check that it's positive. It's positive. Or actually, if you keep this minus, you will see that you get not exactly as required. It's like a hint, actually. So let's check about this term with root of h. Root of h, it becomes this 7560 and root, and multiplied by r squared by 0.023, and you can see that it's as required, and you can see minus. So correct. Then let's consider this term just a number. Just a number becomes r squared 0.23 squared, r squared times 2 times 17,640 and times c. C is 0.013468700, and you can see that it's the same. And it's positive as required, 25, 13, 14, if you round it, so correct. And finally, r squared, so 0.023 to the power of 4, 234 times 2 times this 17, and you can see that it's negative as required, and you can see that it's as required and multiplied by t, so it is equal to this as required, approximately. And the last question: use Euler's method with a step length of 0.5 minutes to estimate the maximum value of capital H3 max. So you remember that the Euler's formula says that the next value of a function, it's the current value plus step multiplied by the derivative at a current point. So here it becomes, let h be u for our calculator. So for our calculator we should choose sequence mode, this one. Then y function, and let u be h, and using the Euler's formula, and for calculator un it's the next value, and u of n minus 1 is the current value. So the next value of h it's the current, so you should write u of n minus 1 plus step. It is given that length of 0.5 minutes, so plus 0.5 times derivative of h, so dh over dt, so the above formula, 0.25 minus, and let t be v, and notice that v also must be like this, v of n minus 1, and minus 0.14 root of u and also of n minus 1, and the initial value of u it's 1. Why? It's because capital H it's for the second or lowest cylinder, and the initial height is 1 meter, so the first value of u is 1. Then v it's time, so v is equal, vn is equal to v of n is equal to v of n minus 1 plus 0.5 because it is given that step length of 0.5 minutes, and the initial value of t is 0, and then just second and table, and we need the maximum, to estimate the maximum value of h. H is u, so you can see that u increases 1440, 445, and you can see here when v its time is 8.5, the previous is 1.445, then 1.4468, it's larger, then it's smaller, so it decreases, so maximum is 1.4468 or 1.45 to 3 significant figures. It's not required when, but we can say that when or at t is 8.5 minutes. It's not required when, just to estimate the maximum value. So maximum value h max is equal to 1.5 meters. It's not required, but it's at t is 8.5 minutes. And that's all for this question.